welcome back to our channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have a presentation from one of our students who has completed the ROS Basics in 5 days course. And at the end of this project, you can do a real robot project in one of our robots here at The Construct. So that is what we're going to be seeing here today. So, hello, Ali. How are you doing?
Hello, Rodrigo. I'm fine.
All right, great. It seems like we had some issues with your camera because you suddenly disappeared. Uh,
Yes, just in 1 minute, I will be fixing it.
don't worry. If you want, uh, at the end we can do the face to face. But right now, I just want to say welcome, and whenever you can start sharing your screen and showing us what you've done with this project.
Okay. Uh, okay, just a second. I will go and come.
Yes, perfect.
Okay. So here is I am. I will be sharing my screen. So hello, everyone. Hello, Rodrigo.
Yes, we can see your screen. Perfect. We can see
Okay.
the robot and the IDE.
This is my project. At first, I will be showing you the results. How is this working? So at first, the robot will be searching for the wall,
Uh-huh.
and okay, so just because it is on the corner, it's facing some problems. I will be fixing this.
Is it not decide? Yeah, I can't decide where the wall is.
Yes.
Could you
Okay.
maybe make the camera window a little bigger so we can see better? Because it's too
Yes,
small for
yes, of
us.
course.
Oh, much better.
Uh-huh. Okay. So here is the robot. Now it finds the wall, and now it start to following the wall.
Uh-huh.
It's trying to keep a certain distance from the wall all the time. And here we can see it correcting the mistakes. So like when she is turning, the distance is changing. She's trying to get closer to the wall,
Yeah,
and I
that's
will
good.
go in the details later on.
You're a fast one, huh? You like it to go the robot to go fast. That's
Yes,
nice.
I have make a PID control, so I
Oh,
have a question
nice.
about this part. I will ask you about it later on.
Okay.
Mhm.
Yeah. How it got kind of stuck or something? Is that what you mean?
No, here it's just at this corner,
Yeah.
the road go closer to the wall than the other corners. I don't know
Hmm.
why.
Maybe I'm thinking, maybe I'm guessing it's because that wall is not receiving light the way the other
Uh-huh.
walls are. So maybe the LiDAR uh, readings aren't as good. That's what I would guess.
Uh-huh. Yes, I think there's something special about that corner.
Hmm.
Yes. So here's the program has finished, and the list of odometries it's produced here. The code will generate for us a text file,
Yeah.
so we can see it in the package, in our package. Here we have the list of odometries text
Oh,
file.
that's great.
Yes, which is contain all the odometries, also the odom bag, and I will talk about it.
Yes,
Yes,
I was going to mention that, but yes, I'll let you go on your own.
yes. We can delete it and then run it again, and it will produce generated for us.
Oh, great. That's awesome. All right, so
So
we can see that the robot found the wall, did a lap around the lab, and then returned a list of odometries. So
yeah,
basically, that's the project. So that's amazing. So could you uh, sort of explain us how you solved each one of these parts now?
yes, of course. So now I want that the robot will do just another lap while I
Okay.
am go explaining,
Yeah,
so we
awesome.
can see everything is generated another time.
Great.
Yes. At first, I want to show you my package. So here we have the wall following behavior package, and we have the action files folder, which contains the action message, the launch folder, the source folder where I put my nodes,
Yeah.
and the SRV folder, which have the message for the service. Yes.
Okay.
At, at first, I will explain a little bit about the following wall behavior. So how I make the robot follow the wall.
Perfect.
At first, I want to show that for moving the robot, I like that not directly using the CMD message, like the twist message. So I make my own move robot function, which is get the Z and X arguments, and then I try to make sure that the robot will not exceed the maximum angular speed or the linear maximum speed. Yes. Uh, this is about moving the robot.
Uh-huh.
Then, uh, for making the robot follow the wall, okay, I use the PID controller. I made my PID controller, so the robot will be moving the wall. Here there's a point. So there's a problem that when the robot is have an angle, so it's not like on the straight line. At this point, the right laser, it is not the distance between my robot and the wall.
Uh-huh.
Because as we see here, my right laser is this B. So I need the perpendicular distance from the wall to my robot. So I have used this geometry equation. So I have added a laser. I have read another laser beam from the LiDAR, which
Mm.
is A. And I used the trigonometry. So I have now this triangle and this triangle. And by substituting the suitable angles, I can know the perpendicular distance. Also, I can know the angle alpha,
Mm-hmm.
which is how much is my robot deviated from being straight. Yes. And then when I went to go to write my PID controllers, the error, so I have I have like target here, a target distance from the wall.
Yeah.
Okay. So the error will be how much I am far from this target. Also, the angle alpha, I want to consider it with the error
Yeah.
because
Yeah.
the angle alpha will cause me errors later on. So what I have did is that I have added the b cosine alpha. Uh, no, I have added L sine alpha. L, it's a completely uh, arbitrary value. I give it to my code.
Mm.
So by increasing L, I will be increasing the value, the effect of the alpha. And I am telling my robot, please respond more strictly to alpha. So I
All
don't
right.
want my robot to have any alpha when it's walking. So here it is. Here is at first here at this function, I have calculated the errors. So this will be the A angle. Of course, we can calculate the angles by knowing the laser index. So here's its function. By knowing the angle minimum and angle increment, we can get the angle. Okay. And I can have the angle for the B also by the same way. And then I can calculate the distance from the wall and the alpha by using the trigonometric equations. Okay, so okay, and then here I have the stop robot, which is stop clear. Okay, and here I have added some function for avoiding the wall because we know the robot will be facing the wall at some times, so we need it to turn. So I have made this function. Whenever there's something in front the robot will be turning. Uh, okay, for the PID controller, I didn't use KI, so
Mm.
it was 0. I put some value for L for the alpha, and yes, here is the KP, the KD, everything just typical PID control. And yes, the robot was moving according to the control output, which is the result of my PID control. Here is how the program run. At first, I will be calling the service. So I have made some function here for calling the service, which is here.
Mm.
Uh, I I will be sending a request to my service, and it will give me information about it on the terminal if everything is okay. Then we go to, after this, I started my odometry recording. So there's an action server. I sent him a goal and it will start working. Then I will be using the PID controller. And when I complete one lap, I told my robot to shut down and produce me and generate for me the list of odometry stacks. Okay, here we have this function which is called get package path. It's
Yeah.
here,
Yeah.
so I can get the path of my package to let my text file be here. So here's
Great.
my file generated. After I deleted, everything is okay working, and this is the odometry. Yes, this is regarding the following wall. Now I will go about the service.
And what does this service do again?
The service, it will have three main functions. Here they are. At first, it will be facing the wall.
Hmm.
Then it will be moving to the wall. Then it will be turning to start moving,
Okay.
walking. So for facing the wall and turning to start walking, I noticed that in reality we are doing the same thing. So we are wanting some side of my robot facing the wall. So at first I want the front side, and at the last time I want the uh, side
The right side,
which
no?
is
I think so.
yes, it's 270.
Yes.
Okay, so yes. So I make one function which is called robot side facing wall, and this function will get an input like side, and also it was just proportional controller. So the logic behind it is that if I want the front of the robot to be facing the wall, I will tell the front laser to be the minimum laser.
Yeah,
So
that's
whenever
the
my
error,
front
right?
laser is the minimum laser, so this means that my robot is facing the wall. Yes, and here I have the K by the error, and the error is how much is how much my front laser or the 270 laser is far from being minimum laser. Okay, so this is will be my error. And here, this is about deciding at uh, being turning clockwise or anti-clockwise. So if the minimum laser is less than my side laser, I will be making it negative. Yes, and so here's the facing wall. It will just be going to this function and tell it to make it with the front side. And here is the turning to start walking. It will go to the robot side facing wall with the 270 side. Yes. And for moving to the wall, also it's clear. So I use the proportional controller another time. And I told the robot to move until I have the desired distance. So I decided to use set point as 0.27 centimeters. Okay, yes. Also, there's a point in my code is about the laser. So for the laser, I have made two dictionaries, but here it's just one in this code. But in the previous code here, we can see that I have two dictionaries. At first, I have a dictionary which is relating for each index for the lasers I need to use, back, right, front, left, and A. And here I have the laser value dictionary. So by using the dictionary here in the laser scan, just by our one loop, I can fill all the data.
Oh, nice.
Okay, yes. This is about the, and here it was the same. Yes, but here I needed more data about the minimum laser.
Hmm.
So yes, I added them. And at the end, when I finish all the three tasks of the service, I will return with the response that the wall is founded. Okay, this is about the service. Here it's about the action service. So for the action service, we need to have our ROS bag recording the odometries. Okay, but the odometries are X, Y, and theta. And the odom topic doesn't have them like normal angle. They are quaternions.
Quaternions, yes.
Yes. So we have added a function here to change them to quaternions, from quaternions to normal angle. It is previous. Okay. Yes, here it is. Calculate theta because only I need theta, Zayao. Also,
You have
uh,
five
be,
minutes left, Ali.
uh-huh, okay. So also because the odometry topic. So yes, I created a new topic which is called for ROS bag. So in the for ROS bag topic, I was publishing the suitable data like X, Y, theta, not quaternions. So I will be recording X, Y, theta. Yes, here is odom. Odom is something I have created. It's 0.32. And yes, I have filled all the data with the suitable data. And then I was recording it. Also, I've added the path to my package. And yes, here it is. That's all.
All right. So then those that covers then the three actions that we saw the robot complete. So
Yeah.
is that the end of your presentation here?
Yes.
All right. So congratulations. Do you mind, Ali, if you can stop sharing your screen so we can see your face here, and while I ask you the
Yes,
questions.
of course, of course.
All right, awesome. So congratulations, Ali. Really nice project, really well structured, and
Thank
really
you.
good robot behavior at the end, which is the goal of the project. I can tell that you went above and beyond the requirements of the project. So congratulations on that.
Thank
Let me
you.
tell you what I really liked about it. So first is your use of controllers, right? So you
Yes.
you said you implemented a PID. Well, it's actually a PD
PD.
controller
Yes,
uh,
yes,
in
yes,
the follow the wall, and then
yes,
another one in the find the
yes,
wall service server behavior. So that means you can have a lot more control over your robot, and that you have some experience with controllers and you know how to implement them. Really simple. And by looking at the errors that you found, that you thought about, right, like that alpha angle, to make sure you're always looking at the value that it represents the wall and not just the right side, that's going to translate into a smoother behavior. So I really, really like that. And then you can also, for example, I saw that your x velocity was variable as well. So because of the control you implemented, you have all these possibilities. I really like that. I also really liked your use of ROS bag, which is nice to see from time to time.
it was
And
not obligatory.
no, no, it was not. But I'm glad you see this, you did this, because I'm gonna ask you some questions about it. And then the other part I really liked, just a simple thing, but it tells me that you, uh, for ROS Basics, one of the most important parts is to understand your package structure and where everything should be in the packages that you make. And for example, I saw that you made that get package share function, which finds you the path where of the location of your package, so you can then put your txt file in the correct location. Now that might seem like an arbitrary thing, but it's very important to do these things correctly, and I can see that you did that. So for that, congratulations. Uh, Let me ask you some questions, though. So my first question is related to the finding the wall service, and I'm asking it because we saw it happen in the first try, right? You were near a corner, and you could kind of see the robot sort of uh,
Yes,
go back and forth. Is that
yes.
why is that?
I think because when the robot is moving, while it's moving near the corner, then the minimum laser is changing.
Yeah, you got two values. Yeah.
Yes, so every time he go in a certain direction, then there's a new minimum is coming, so he don't know what to do.
Right,
Yes,
right. And I ask this because it's an interesting scenario. For example, this, I think I remember this used to happen in old Roombas, um, where the ones that have a lighter on top, because the really nice ones have a lighter and everything.
yeah,
And there'd be a situation that this happens. You know, you could see it reach a point where it would sort of get stuck. So
yeah,
the way they solved it, and I mean, you can add, again, you can add so many fixes to these behaviors, is detecting the angular velocity change signs for a certain
mm,
number of times, and say it's doing it 10 times and it's not moving forward, so let's just move it a little bit and try again. So
yes, yes,
but
yes,
I just wanted to make sure you understood why that was happening, and yes, I can see that it and you do. So the um the other thing that I wanted to ask you is the ROS bags. So we do not explain ROS bags in this ROS Basics course, but it is a great tool to record data that you are interested in for later use. So I wanted to ask you, so you record your ROS bag to get then the odometry values, right?
Yes.
So basically, every time you run it, you then have a new list that you've saved in your. Well, we deleted it and then run it again, but so that's a great way to use a recording of a movement to then, I don't know, do more filtering with it. What I didn't understand though about your ROS bag is that you mentioned adding a new topic for to ROS bag or something like that. Could you go a little bit further into that?
In the course, they talked a little bit about ROSBAG, so I thought it's obligatory here in the project to use it. But regarding that new topic is because the theta angle it is as quaternions in the odometry
Right.
topic. So I wanted to record them as theta, not quaternions.
Roll pitch, yo.
So
Yeah.
yeah. So I make a new topic. So at this topic, everything is x, y, theta, just as I want.
So you're recording only that topic.
Yes.
Ah, I see. So you process the original odometry topic that comes in a quaternion, you convert that to roll pitch yaw, and then that's the topic you are recording, so it makes more sense.
Yes.
Ah, I see, I see. That's good, that's good. All right. So, I mean, other than that, Ali, I don't have any other questions. It's a really good project, really well behaved, fast, which is nice to see, and that the control was able to handle it, um, that
Thank
speed.
you.
And I just want to congratulate you again and thank
Thank
you.
you very much.
All right. So let me just mention for everyone that is watching, you can do this once you complete our ROS Basics courses and ROS Navigation courses, actually, in both ROS 1 and ROS 2. So you can do what Ali did here and present what you've learned throughout the course in order to first consolidate your learnings and be able to get one of our certificates of learning to make sure you took something out of this course. So I invite everyone that is watching to do what Ali did here for your projects. And Ali, thank you again one more time, and I hope to see you next time for the next presentation.
Thank you. Thank you
All
too very
right.
much. I have enjoyed the course and the project.
I'm glad to hear that. I'm glad to hear that. All right. So that is it for us here at Becoming a ROS Developer. We'll see you for the next presentation. All right, guys. Bye-bye. All right, cool. We are done.